Due to the current problem of cadmium and lead contamination in food samples, many organizations involved in quality and safety control currently focus on developing a series of measurements to detect these metals using a variety of methods. Generally, most standard methods rely on the use of sophisticated and expensive apparatus that require a large chemical and sample consumption, like the ICP-OES method. An alternative method that can be used to measure quantity of cadmium and lead accurately and affordably is electrochemical measurements. However, the previously reported electrochemical measurements still require complicated electrode preparation process, making them impractical for use outside the laboratory. Therefore, a paper-based electrochemical measuring device, which is simple and inexpensive, is introduced in this study. One modification step is integrated into the sensing step and thereby reducing complexity in electrode fabrication. The fabrication of the single-step paper-based electrochemical sensor includes two steps, which are wax printing and screen printing. There are three associated electrodes in the process: working electrode, reference electrode, and counter electrode, as well as the sample solution dropping area. Anodic stripping technique is applied by dropping bismuth solution on the electrode surface, which is sensitive to even a tiny quantity of heavy metal in the solution. How the device works is that, first, we drop the food sample on the testing area, then analyze it with the square wave voltammetry technique. Before using the food samples according to the method mentioned, cyclic voltammetry was performed to check the quality of the electrode, whether it worked properly or not. Furthermore, modified electrode and bare electrode were compared, matching with the result of blank condition. And for sure, the current signals from the bismuth modified electrode were remarkably enhanced. The increase in stripping currents could be observed due to the bismuth providing increased surface and facilitating a better deposition due to the formation of amalgam with lead and cadmium. This electrochemical measuring method also including optimization process, which the most satisfying and acceptable conditions are deposition time for 180 seconds, deposition potential is a negative 1.6 volts, with 10 ppm bismuth solution. Moreover, there were the results from analytical performance process, which was evaluated with square wave anodic stripping voltammetry technique. Concentration of cadmium and lead were varied in order to use in the further step. The concentration of one was fixed and another was varied. Since the current of cadmium always significantly higher than the current of lead, to be sure that peaks can be observed properly with no overlapping, the following conditions were chosen. Fix cadmium at 0.5 ppm, then vary lead. On the other hand, fix lead at 0.5 ppm, then vary cadmium. The relationship between the concentration and the current was linear, with the range from 0.021 to 1 microgram per liter of cadmium and 0.5 to 1 microgram per liter of lead. Not only that, but also the value of limit of detection and value of limit of quantitation were calculated and resulted in the acceptable range. The proposed sensor was applied for the determination in various water samples with acceptable recoveries in the range of 86 to 106%. Overall, the paper-based sensor exhibits significant advantages over the previously used methods in these following aspects. It uses a less sample, less time for detection, and it is portable, easy to decompose, while it also helps reducing the manufacturing cost. In the future, we hope that the sensor will be developed to determine more kinds of heavy metal. Moreover, it would be more beneficial if the range of samples tested was extended to biological samples. We strongly believe that the test kit will help facilitate the analysis of cadmium and lead contamination in food samples, as well as aid any further plans to reduce heavy metal contamination in food samples.